take a look at the solution to this question. Hopefully you got some or most of these. So in part 1, we want to select the equivalent expression to this guy right here and then select the restrictions. So this guy right here, we have a square root in the denominator. We don't like that. So I'm going to write it out. But then I'm going to multiply by the conjugate. So that's square root of x, flip the sign, plus 1. Okay, now let's simplify. So in my numerator, I'm going to get an x minus 1 times a root x plus 1. Some students I know want to automatically expand this, so they want to do x times root x times 1, negative 1 times root x, negative 1 times 1. Don't do that just yet. Okay, just write them out as 2 brackets because a lot of times things will simplify, as we'll see later on in this chapter. In the denominator, we have a minus b, a plus b. That's going to give us a squared minus b squared. Oh, look at that. X minus 1 in the numerator, x minus 1 in the denominator. We cancel those out. This is the same expression as root x plus 1. Okay? Of course, for us to be able to cancel that out, x couldn't have equal 1. If x equals 1, we can't divide 0 by 0. That would fall apart. So my restriction here is that x cannot equal 1. And also, because I start off with x being in a square root, I also need my x to be greater or equal to 0. So the correct answer that matches with this is this expression right here, root x plus 1. And I do see that x is greater or equal to 0, and x cannot equal 1. Okay, part 2. Again, we see a square root in the denominator. So let's have x over root of x plus 4 minus 2. And this time we are going to multiply by the square root of x plus 4, flip the sign, plus 2, divided by the square root of x plus 4 plus 2. Okay? So again, in the numerator, don't try to expand things out. Just keep it as x times the square root of x plus 4 plus 2. And then in the denominator, I'm going to pause the video, write down what it is, and if you can, continue to simplify. So hopefully you got this in your denominator. We have a minus b times a plus b. So that is a squared, which gets rid of the square root, minus b squared. Okay? And then from here in the denominator, notice that 4 minus 2 squared, those cancel. So we're left with x times the square root of x plus 4 plus 2, divided by just an x. Oh, look at that. The x's cancel. Of course, in this case, x could not have equals 0, because if x equals 0, I'm not allowed to do this cancellation. What other restrictions are there? Well, I also see that my x plus 4 is underneath a square root, meaning that x plus 4 has to be greater or equal to 0, meaning that x is greater or equal to negative 4. Okay, so if you look at my answer options, the one I want is the square root of x plus 4 plus 2, right here. And x is indeed greater or equal to negative 4, and there should also be an x not equal to 0 there. Okay, part 3 looks a little scarier. It's math without numbers, but don't worry, follow the same steps. First of all, I notice that I have 2 fractions, and those are in my numerator. So I'm going to try to combine them into one fraction first. To combine them into one fraction, I need a common denominator. The common denominator is going to be the square root of x plus h times the square root of x, meaning I need to multiply the first chunk by square root of x in the numerator and denominator. So I get the square root of x over square root of x times square root of x plus h. Second fraction, I need to multiply top and bottom by the square root of x plus h. So that's the square root of x plus h divided by square root of x, square root of x plus h. And don't forget, I'm dividing everything by an h. I'm not changing the question because I'm just multiplying essentially by 1 to each fraction. But now I can combine this and I get the square root of x minus the square root of x plus h divided by square root of x, square root of x plus h. Because they're common denominator, I can just subtract the numerators. Where does this h go? I'm going to let you think about this. Who thinks h is going to end up in my numerator? Who thinks h is going to end up in my denominator? Well, since I'm dividing something by a number, you can think of it as dividing by h over 1. Then it becomes flip and multiply. right? That's how we divide by fractions. So we're multiplying by 1 over h in my numerator. So if I multiply by 1 over h, my h is going to end up in my denominator, okay? So this is going to be square root of x minus the square root of x plus h divided by h times the square root of x plus h. That is my expression. But if you look at any of my expressions, I don't see that in my options. So instead, I'm going to have to multiply by the conjugate. Okay, I'm just going to start it down here so I have a little bit more space. So again, our expression that we left off was this guy over here. I'm going to multiply by the conjugate. This time I notice that my two different radicals is in my numerator separated by a minus. So I'm going to multiply by root of x plus, flipping that sign, root of x plus h divided by root of x plus the square root of x plus h. Okay, let's do some crunching here. In the numerator, I get an a minus b times an a plus b, so that gives me a squared minus b squared. Divided by this whole thing. Don't try to expand it because a lot of times, remember, things are going to cancel. So just leave it like this for now. Okay, let's simplify. In the numerator, I have x minus x, which goes away, and then a minus h. Don't forget that negative sign. Okay, like we promised, some things will cancel. So the h and the h cancel, and we're left with -1. Now, we could expand this denominator. Let's see if any of the answer options matches that. I'm looking for things that have a -1 in it. So it's either this guy right here that has the -1 or this guy right here. Notice that they do look like they've been simplified a little bit. So let's simplify the denominator. So multiplying this through, I'm multiplying the square root of x plus h by the square root of x, and then by the square root of x plus h separately. So the first term, square root of x times square root of x is just an x, and then square root of x plus h, plus, second term, I have the square root of x, and then square root of x plus h times square root of x plus h is x plus h. So now it's more clear that my answer option is going to be this fourth one, and the restrictions, let's see if those make sense. I'm actually going to use this guy right here because it's right next to it and it's easier to see. H cannot be 0 because it's in the denominator. X has to be greater than 0 because it's under a square root in the denominator. And x plus h also has to be greater than 0 because it's in the square root under the denominator. Okay?